Hello, I'm John Klobuchar with InEight, and I'd like to welcome you to the latest webcast in our Planning, Scheduling, and Risk series. Today's webcast is titled, Why You Need AI-Driven Project Risk Analysis. Our presenter today is Dr. Dan Patterson, who is InEight's Chief Design Officer. In this role, Dan focuses on expanding upon his vision of creating next-generation planning and scheduling software solutions for the construction industry. Dan is a certified project management professional by the Project Management Institute. If you have any questions as you watch the webcast, please email them to webcasts@ineight.com and Dan will do his best to answer them. Also, this presentation is being recorded and we'll be sending you a link to the video in about a week's time. Once again, we're glad you've joined us, and now let me introduce Dan Patterson.
Well, thank you, John. So I'm very excited about sharing my thoughts with you as to why I believe this emerging technology known as artificial intelligence, or AI, is proving to be incredibly valuable to the science of risk management and risk analysis, and specifically how it's benefiting owner organizations within the project management space. Now, when you think about a project, it's very interesting, again, from an owner perspective, because really the project execution phase is really the riskiest phase of the entire project. Now, taking that a step further, really the project investment, while that risk is carried by the owner organization, really the owner is held hostage by the fact that it's the contractor that is actually executing the work. And so this science of applying or considering risk and uncertainty and applying it to our cost and schedule forecast is, and has been for many, many decades now, very vital to owner organizations. Having said that, I think that traditional risk analysis is somewhat of a reactive measure to project planning. And I think with the advent of artificial intelligence, we're now starting to turn that on its head, and we're really becoming much more proactive, and we're accounting for risk and uncertainty during the planning phase. So what I'd like to do is, first of all, just touch on some of those traditional risk analytics concepts, and then take that forward and share with you some of these next generation artificial intelligence risk analysis concepts, and close off on, again, another emerging, really more of a best practice, commonly known as advanced work packaging, or AWP. And I think AWP is very interesting in that, again, it's looking at planning from a different perspective, and we'll get into the details of that towards the end of the session. So I think it's very important to understand that risk on a project is very different depending on whether you're sitting on the owner side of the fence or the contractor side of the fence. From an owner perspective, really what we're doing is we're trying to validate that the amount of capital expenditure that we are going to allocate to this venture is appropriate. And so very often, when we're doing our risk analysis from an owner perspective, the most cost-sensitive variable in our project is time. So really, schedule risk becomes more impactful than just pure cost uncertainty itself. And very often, again, CapEx projects have a terrible reputation for overrunning with regards to time. Some of the drivers behind that are things like the incredible number of parallel paths within a capital investment project. Very often you have competing work phases, limited resources. There's also a huge degree of dependency really between the sequence of, okay, well, let's design, then procure and fabricate, deliver on site, and then install, and then commission and close out. So that very highly sequential set of dependencies really puts the owner organization at extreme schedule risk. Now, conversely, looking at risk from a contractor perspective, really from a contractor perspective, the contractor cares more about money than time. So all the way back to the bidding phase, the contractor is wanting to make sure that, again, by doing a risk analysis, they have allocated sufficient contingency to protect themselves from what we call margin erosion. Now, the focus of today's session is very much risk from an owner perspective. Traditionally, even before risk analysis became mainstream, which I would suggest has really only been in the last probably 10 years or so, traditional estimating and scheduling I would suggest has really generated a best case scenario rather than a most likely scenario. A planner or scheduler will develop a schedule forecast, but very rarely will that forecast include some of the potential unknowns and the bad things in the form of risk events that potentially could happen during execution. So really, that plan assumes uneventful, perfectly executed as per plan. Now, as we all know, the reality of that is that very, very rarely happens. Now, introduce risk-adjusted forecasting, what we're doing is we're taking that best case scenario, that best case forecast, and we're overlaying those uncertainties, those risk events, those negative impactors that will typically increase the duration. And I think, again, it's helped somewhat in that, forecasts now carry these contingencies. I think one of the downsides to traditional risk analysis, though, has been, again, it's a reactive measure. We generate our forecast, we set a stakeholder expectation, and then we come back and say, oh, by the way, actually, we need to add another 20% contingency. Wouldn't it be better to understand the risk and uncertainty up front and really level set those expectations right from the get-go? So I know many of you are very familiar with the traditional risk analysis process, where we start off with, again, what we call a deterministic forecast. We strip out any contingency that's already built into that forecast, because ultimately that's what we're trying to ascertain through the risk analysis. We then model the risk through two variables. First of all, what we call uncertainty, and secondly, what we call risks. We then do a risk analysis. The risk analysis is really a brute force approach of, we call it a Monte Carlo simulation. It's effectively running the project or executing the project thousands and thousands of times. And then out of that comes the risk results. I think, some of the key drivers or key leading indicators, things like confidence levels, obviously contingency is very important, but probably more importantly, what are the drivers causing that contingency or causing the requirement for that contingency? So I mentioned the two variables that we use in modeling uncertainty and risk events. And again, really just to close off on this, think of uncertainty as, this isn't a very technical phrase, but I think of it as the wiggle in a risk model. This is uncertainty pertaining to things like quantities. And often, we get inherent quantity growth during the 30, 60, 90 design phases of a project. In addition, things like productivity rates carry a high degree of variability. So in both instances, whether it's quantity growth or variability of productivity rates, this is really just variability of forecast. Now, that's very different to having an accurate forecast, but still being exposed to discrete events such as a labor issue or a mechanical failure or rework during commissioning. That type of risk is triggered or caused by a discrete event. They are called risk events. What we do is we take a combination of the uncertainties, the risk events, and we combine them together into the risk model. Now, again, over the years, there's been literally tens and tens of risk reports generated. Ultimately, I believe there are two key reports you should use for risk analysis: the risk histogram and the risk tornado, or the what report and the why report. The what report on the left-hand side explains our risk exposure, our range. It gives us insight into how much contingency should be thrown at the project. Again, that's all very well, but if I'm looking to reduce my risk, I want to know the why. Why is my risk range so many weeks, so many months, so many dollars? The tornado chart on the right-hand side tells me exactly that. It is a prioritized list of not only risk events, but also schedule and cost estimate hotspots that, if we can mitigate and reduce down the uncertainties and the risk events, will increase our confidence and reduce the amount of required contingency. Moving on to artificial intelligence and machine learning, one of the big challenges with traditional risk analysis has been to accurately capture those inputs that we just described. Now, with artificial intelligence, we have the luxury or the benefit of leveraging historical project information. So prior project schedules, prior project cost estimates, even previously built or generated risk registers can now be not only stored in a computer or a knowledge library, but more importantly now, with AI, the computer can actually interrogate that unstructured data and start to now make suggestions back to the planner and the scheduler during the planning process. So what that's really doing is it's now taking this concept of accounting for uncertainty and accounting for risk events. It's moving that process directly into the planning process. So again, that's now eliminating the need to build a plan and then reactively come back and throw contingency at it. I think another massive step forward with regards to AI has been that we're now eliminating some of the statistical complexity that legacy risk analysis carried with it. So previously, we would interrogate or interview team members and ask them for example, 3-point estimates or 3-point distributions. Can you please describe this duration in the form of a best case, most likely, worst case scenario? Well, that's actually very difficult to extract that information out of a team member. So what we've done with AI is we've said, look, if we have these large quantities of historical data that we can effectively match up and look at analogous scopes of work, we can automatically generate those ranges. And again, the benefit there is they're not just limited to 3-point estimates. If we have 10 historical projects in our AI knowledge library, we end up with an input distribution that has 10 points, not 3 points. So it becomes much more accurate. This really boils down to complete avoidance of garbage in, garbage out when building a risk model. Another massive benefit of AI when building risk models is the ability for the computer to make suggestions with regards to risk events. Again, generating a project risk register is actually quite an onerous process. We've reduced the overhead and the complexity of the development of a risk register by, again, allowing the computer to make suggestions as to, okay, well, I understand the context of the scope of work within which you are planning for. Historically, these are common risk events that occurred. Not only that, these were the impacts with regards to schedule and cost. Well, that's an incredible step forward because now we can start to build our risk register not only on human expertise and largely expert opinion from project stakeholders. We're now able to validate and calibrate that risk register, again, based on historical reality. So to try and simplify this whole process of artificial intelligence and how it applies to risk management, we've broken down the entire process into 6 steps. On the left-hand side, we have knowledge administration. This is really the knowledge capture part of artificial intelligence. This is taking those historical schedules, cost estimates, risk registers, and storing them in the risk register. And then as part of that process, undertaking what we call a knowledge cleansing exercise, and then tied to that, calibrating the AI algorithm through what we call machine learning. Once that knowledge has been established within our project or organization, we can then actually leverage it during the planning process. And the 3 steps on the right-hand side outline that. So let's take a little bit of a closer look. So step 1, this concept of knowledge capture, I think really the most important point to note here is we have moved away from forcing data to be stored in highly structured, for example, SQL tables. Instead, now we can literally throw any form of historical information into a knowledge library. It's called unstructured data. And again, I think the big breakthrough with regards to AI and risk analysis is the fact that we have now developed a means for the computer to interrogate that unstructured data. We call this an inference engine. The inference engine is smart enough to understand context. Context is absolutely key in AI. So understanding context, the computer can interrogate those large volumes of historical knowledge and again start to come back with suggestions. Now, in order to understand context, some of that knowledge, first of all, has to be cleansed and enriched. So again, we've developed this concept whereby knowledge can, through what we call knowledge tagging, be it can be first of all cleansed, but also it can be added to. So for example, if I load in a historical schedule, telling the computer things like the geographical location, the type of work that was involved, the contract terms for that project, so on and so forth. If I can tag and enrich my schedule data with those attributes, then again, at runtime, when the planner, scheduler, the risk team are asking the computer to make suggestions, it can make smarter suggestions because it has more context. I think another big step forward we've made with regards to certainly risk-adjusted scheduling is I think we've come to the realization that there is huge value in, first of all, creating a big picture top-down schedule forecast. During the leading up to project sanction or FID, there's really no point building a 10,000 activity Primavera schedule. That's ridiculous. There is, however, huge value in creating perhaps a 300 or 400 activity top-down forecast where the durations and the costs and the identified risks have been validated or benchmarked, again, based on historical comparisons. Now, I believe one of the huge benefits of creating this top-down forecast in the very early stages of the project is then to follow through, and as the project then is sanctioned and we start to do our more detailed planning and forecasting, to take that top-down forecast that is largely built upon or built up using what we call planning packages, to then start doing more of a bottom-up where we build in our detailed CPM activities, our logic, our calendars, our resources, all of the common building blocks that we use when building a very detailed schedule. The key, though, is marrying that up to that top-down plan. That top-down plan becomes our framework. It becomes our target. Then we can start to detail, again, bottom-up. We actually then have a sort of a self-calibrating target against which we're marching towards. What we're trying to do is build our detailed plan all the way down, and I'll show you this in a couple of minutes, all the way down to daily plans. We're aligning that with that big picture CapEx forecast. And again, that's a huge step forward. Not only that, when we're building our bottom-up plan, because the computer now is making in real time suggestions as to the duration ranges, the risk events, the cost uncertainties, the potential quantity growth, all of those risk model variables are being embedded into the plan up front. And the screenshot on the right-hand side here is actually a very good example of me, the planner, as I'm building out my CPM schedule. In real time, I'm able to understand the impact of those uncertainties and those risk events. I don't have to take my schedule, load it into a very complicated risk tool, run my risk analysis, interpret the results, and then try and feed some of that back into my schedule. This is all being portrayed to me through risk-adjusted reporting, again, in real time as I build my plan. And again, I think that's a massive mindset change with regards to risk modeling. I think gone are the days where we first of all build a plan and then build our risk model. No, we are starting out of the gate building a risk-adjusted schedule. So I mentioned daily planning. I think one of the shortcomings, certainly from a software vendor perspective over the last certainly 20 years, has been the fact we have focused very much on providing the industry with planning tools. Now, that sounds probably a little bit silly. What I mean there is we've focused on providing planning tools for the planning phase of a project. We've really not done, I don't think we've done enough service towards building planning tools for the execution phase of a project. And so as a result, out in the field, a foreman, a superintendent, yes, they will look at and certainly review the big picture CapEx CPM schedule. But then when it comes to daily planning, they'll either use a whiteboard or post-it notes. So what we're doing now is we're saying, well, actually it makes a lot more sense to build those daily plans, and sometimes they're called short interval plans, to build those daily plans against the framework of the CPM schedule. And again, tying that to risk, if our CPM schedule has already been risk adjusted, it's incredibly valuable for the foreman or the superintendent when building out those daily plans to understand, again, from the computer, oh, okay, for this particular week, we're working on, let's say, for example, we're doing a concrete pour, and then we're going to start looking at structural steel. Well, historically, these are the risks that occur during the concrete pour. And so as a foreman, I can start to take into account those risks and plan and adjust accordingly. So for the first time now, we are marrying up front-end planning during the planning phase, modeling using risk-adjusted CPM schedules, and again, marrying that up now with field execution such that foremen, superintendents can create their daily plans, but again, more importantly, tie it back to the CPM schedule. And all of that planning, whether it's front-end planning or field execution planning, has all been enriched or we're adding and understanding the impact of risk and uncertainty. So that gets us into this concept of what I'd like to call a digital thread. I've introduced the concept of, let's not build a 10,000 activity schedule up front. Let's create a high-level, top-down forecast. Then let's do our bottom-up CPM scheduling, and then take that CPM schedule and use that as a framework to do our daily planning. Well, essentially what we're doing there is we're providing continuity of knowledge or continuity of information. So we're starting off with those high-level quantities and those high-level deliverables. We're then building our detailed plan where we're taking into account rates and quantities to derive durations. And then we're getting, again, into the details of field execution. Well, think about it. We're starting off with top-down, and we're ending up with incredibly detailed daily plans and information pertaining to those daily plans. We're building a digital thread. Again, I think before the advent of artificial intelligence and the ability for us to store large quantities of knowledge and information, each of those three phases were not only completely separate, but we would start from scratch every time. So yes, we might build a top-down napkin forecast, but then we'd start from scratch when building our CPM plan. We'd start with a blank whiteboard when doing our daily planning. No, instead now, we're constantly enriching that knowledge throughout the project lifecycle. And again, because we're storing that in a knowledge library, the next go around when we start or create a new project, we have the luxury of starting with that knowledge again, rather than starting with a blank sheet of paper. So that gets us into this topic of advanced work packaging, or AWP. So AWP, I think, is very interesting in that it's really a fresh look or a fresh philosophy behind project planning. So first of all, AWP turns planning on its head. Traditional planning says, okay, we're going to start from left and move all the way to the right towards project completion, and we're going to plan out the project. AWP says, no, that's wrong. AWP says, let's start with a defined completion or finish or target date. What we're then going to do is we're going to model the key sequential execution or construction steps that are needed to achieve that project completion. Those steps or those blocks are known as what we call the path of construction. The path of construction, as the name pertains, is entirely around and about field execution. There is no procurement or engineering or design scope within a path of construction. Now, what's really interesting here is this path of construction, it's very high level. In fact, a path of construction or a POC can be literally a level 1. It can be 10 blocks, sequential blocks leading up to project completion. What I think is really powerful about that is we're effectively baselining and snapshotting our desired target. From that desired target, then we work backwards. So working backwards, what we're trying to understand is what are the procurement deliverables? So we call those work packages, procurement work packages. What are those PWPs that are needed in order to achieve on time, and we call this constraint-free execution? Going back a step further, we then look at the engineering work packages, the design elements that are needed in order to satisfy on-time procurement. So what we're doing here is we're first of all working backwards from project completion back to project start. And secondly, we're starting with this level 1 path of construction, but then we're detailing it down all the way down to those engineering and procurement and construction work packages. Now, again, I think that's a big step forward, but I think the magic of AWP then comes into play when we say, okay, once we've got that plan, on a rolling wave basis, we're going to take those engineering and procurement and construction work packages and we're going to throw them over the fence for field execution. Well, at that point, they become what we call installation work packages. And those installation work packages then form the basis of those daily steps, those daily plans that we alluded to earlier. Now, again, tying this back to risk analysis, what we're doing is if we're working backwards from right to left and we're working top down, well, we can apply the AI risk analysis process that we just walked through where we do our top down level 1 path of construction, and then we backfill with our engineering and procurement work packs. Those engineering and procurement work packs themselves, because they've already been risk adjusted, we're coming up with a much more realistic sequence of work in order to satisfy that path of construction. So I am so excited about really the coming together of next-gen risk analysis being powered and augmented by artificial intelligence, but then marrying that up with this concept of advanced work packaging or AWP. We've been spending an incredible amount of time and effort and certainly focus at InEight on really perfecting this AI-driven risk analysis concept and then again applying that to AWP. And I think really, it boils down to a three-pronged approach. We are absolutely embracing AI. We're really looking at AI as more of augmented intelligence rather than artificial intelligence. The reason being, I think, we need to think of the computer as assisting rather than replacing the expertise of a project team and certainly a planner, scheduler, cost estimator. We're taking into account the expertise of the team members and the stakeholders. We're taking their expertise and not only storing that in the knowledge library, but then leveraging that knowledge. And then thirdly, this concept of risk intelligence. Again, let's take into account risk up front such that the plan we're generating is risk adjusted. Let's not think of risk analysis as something we have to do after we've built our initial plan. So tying that back to owner organizations, again, I think, by applying AI, HI, and RI, the owner upfront, even during the very, very early phases of a project, even during concept select, I think the owner organization now has a much, it's not necessarily a deeper insight necessarily as it's the same level of depth. It's the fact that they're now able to hang a much higher degree of confidence against their cost forecast and their schedule forecast when making the go, no-go decision as to whether that project should be sanctioned and ultimately executed. So that concludes today's session. If you have any questions or comments, our contact information is on the screen here. And again, I'd like to thank you all very much for spending your very valuable time today. Thank you.
Thank you, Dan. Again, if you have any questions about what you've seen, please email them to webcasts@innate.com. To learn more about InEight as well as our planning, scheduling, and risk solutions, visit InEight.com and click on the Request a Demo button. And if you'd like to see a schedule of upcoming webcasts, visit InEight.com/webcasts. Thank you for watching. This concludes our presentation.